Hello guys, let me try to help you with some definitions and examples with this topic, algorithm and data structure. I will try to give you some examples in order to understand this topic. This is not a complete course, obviously, but let me give you some little advice in order that you can pass your test. So, first, what is an algorithm? An algorithm, it's a well-defined computational procedure to get some values, and when I say values, I can think in input. This is going to be, for any reason, I have some information that I'm going to call the inputs, and it's going to be a computational or series of steps in order to convert the input into the output. And the output is going to be the result. Once we made some series of steps, we make some procedures, or we do some algorithms in order to have one result of one problem that we are looking for. So let me give you one example about the sorting cards or sorting numbers. Have you ever been in the casino and you start to gaming some card games, Uno or I don't know, any number, that once you have your bunch of cards, you start to sorting or ordering the numbers in order to see the complete series of numbers, and you can clear any action when your hand is going to be, or you're going to do some move. So for that, we have something in our mind, or the algorithm to start. We can say in one vector that we have the A1. The A1 is going to be belong to the first number. Also, we have the A2. The A2 is going to correspond of the second number. And so on. We will have an undefined number, because we don't know how long is going to be the series of numbers in this vector. So, we have a series of numbers, but this is not enough. We must have some rules in order to give one sense. If we want a sequence of numbers, we can place some rules that say, an example, if A1 must be less or equal than A2. That means if you put the number 7 and the number 33, that computational procedure is going to be okay, and that makes sense to the series of your numbers. If you put an example, the number 2 and the number 2, also this is a good procedure in this computational series of numbers, because the number 2 is equal than the number 2, which is located in the A1, and the 2 is located in the A2 in this section. So let's start to give you some examples in this vector. When I say vector, I'm calling this part, okay? So let me give you one example, which is here. Okay, let's think about in the number 5, 2, I don't know, 4, 6, 1, and 3. We have these numbers, and we want to give some order to these numbers. So first of all, we can think in that A1 is going to be less or equal than A2, and so on, and the AM. This is going to be our procedure in order to compute or sorting this series of numbers in this vector. We need one index. The index is not going to be the number 5. is going to be the number 2 that is going to compare with the pile or the length behind. So the 2 compares in this way. The 2 is less or equal? No. So the number 2 is going to pass to this section, and the number 5 is going to pass to this section. Remember, the number 2 is going to be our index. That compares with this part. So, in our next sorted vector, the series of numbers is going to be the number 2, 5, 4, 6, 1, and 3. This is the new range of the vector. Now, we pass with the index that is not going to be the number 5, it's going to be the number 4. Number 4 has the same situation, so the number 4 is going to occupy the section of the number 5, and the number 5 is going to occupy the section of the number 4. So, in this way, we will say that the new sorting is going to be 2 of 4, 5, 6, 1, and 3. This is going to be the next section. Now, I'm going to erase a little bit. Once we have this, we can think in this section of the numbers, and this is a correct procedure because the 5 is less than the number 6. So this is okay. We pass to the number 1. In the section of the number 1, this is going to be our index, and this is really important because this index will be compared with the rest of the pile. So the number 1 will occupy this section, and that is why important. That is really considered deep information that the index number will be compared with the length of the rest of the pile. So the number 1 will pass to the number 2, and the number 2, the number 4, the number 5, and the number 6 will occupy the next following section, doing this. The number 4 will occupy this section, the 5 will occupy this section, and this will be occupy this section. Because the index go there, the new arrangement, it will be 1, 2, 4, 5, 6, and 3. Now, in this section, the index is going to be the number 3. In this section, the number 3 will be compared with the rest of the length. So it's this going to be in this section, and the rest of the numbers will give a little jump to the next. Gives sense to the algorithm. So now the algorithm will be 1, 2, 3, 4, 5, and 6. And maybe you can say, well, it's really simple, everybody can do this. But it's really important, the series of steps. We gave F, A, B, C, D, E, F steps to this algorithm. And we place not this index, not the first number, but the second section of the number. We gave the index in order that compare with the rest of the numbers. This is really good because if something wrong, it can be arrangement with the line. So now we have our output. This is going to be the output or the result of these sorted numbers or vector sorted. So we want to do the same, but with one algorithm that I can write in C language Pascal, Java, or Python, or any another, you know, computational procedure. So let's start this section with 1 for. Why with 1 for? Because for is going to be a looping. As you can see, we start to given some index and doing repetition. So that's why the for is going to be really important. The for will be some rest of repetitions that's going to be here in this loop. The for will be gave some index with the j. The j is going to be, remember, the number 2. So this is going to be our first section. J is going to occupy the second section, and this is going to compare to the length. The A length. We call that the for will be start with the index, and this index will compare with the A, this is the name, and the length, This is going to be some kind of comparison. We also have one key. This key is going to be the A, this section, and into the array J. This section that is here will be called, or is going to be equal to the J. Now, let's make one comment here. This section is just for a comment. That AJ is into the sorted sequence into the A1 minus J. 1 J minus 1. This is going to be one comment, and I'm sorry if I put here is going to be equal K. We want space for this for because we want to give some ordering. So now the I is going to be the equals to the J minus 1. J minus 1. This is what there is a comparison, and this is going to be the I, the new name that we want to sort it. Once we have this, we can give one while condition looping. So while I is going to be greater than 0, and another condition that A of the array is going to be equals no, A, I'm sorry. Is going to be less than the key. If we have this, well, we can say that the A is going to be I plus 1. In this part of the section is when the number go further 1 steps. This is when it starts to jump in. So we can say that I minus 1 is going to be equals to the I. And we finish with the key. A in the array I plus 1, this is going to be equals to the key. Now, once again, we occupy these 4 and put in here. This is going to be the same when you are writing something in Python. And we have our loop here. This part is when the numbers start to jump into the next steps. If in the key there's a comparison, I is a j minus 1. So I will try to compute this in Python and show in the next video. I'm hope that this is going to be a little bit fast. If you have comments, please let me know in order that I fix it, something that I have wrong maybe in my explanation. Tell me, and see you next time. Thank you for watching this video.